All right, here we go. Well, we're very late now in the etching part of making a copper copper electroform of a microwave waveguide component. So when you looked at this part about a week ago, what you would have seen looking down through the piece was almost solid aluminum, except for about a 1/4-inch diameter hole being drilled out through the aluminum that filled the interior of this part. The interior dimensions here, that circular diameter we're looking at, is about 0.9 inches. So almost an inch across, almost 2 inches across on the entire circular waveguide flange we're seeing there. So what we're seeing right now is the very end of etching out the aluminum from this part. I'm a little suspect. I'm not even sure the bubbles that we're seeing coming out of the piece relate to etching away, reacting with aluminum and dissolving aluminum from inside the part. I think they might be. I think if they were just boiling taking place, I don't know why you wouldn't have boiling off of the bottom of the part where it's more directly in contact with the heat of the hot plate. So I think there's a fair chance we're actually still etching out aluminum. The reason I'm not certain about that is that when I had the piece out of the bath of etchant, out of the sodium hydroxide and water solution, the only aluminum I could see in there yet was just a tiny little nub of aluminum, almost like the point of a pencil sticking out from the wall, the last little bit of aluminum that hadn't been etched away. It is possible, though, that there's still some aluminum, more or less a very thin layer on the surface, almost intermeshed with the surface material. So that's my guess, is that we're actually still etching out aluminum, but it's a little bit confusing. I guess I could turn the part over in the bath and we'd get a better idea whether we were seeing boiling somehow off of that surface. It's not important, though. There's no downside to leaving the part in here for a few more minutes. And actually, I think I see the bubbling rate slowing down right now. So that would indicate that it actually is the last little bit of aluminum that's being etched out. So we're very close to having this finished as far as the chemical activity goes. Now you look at the part, it actually looks much cleaner than it did a day or two ago. While you're doing the etching like this, you get a lot of a dark, kind of filmy substance builds up on the part typically. I think it's actually known as smut. It's probably related to the type of aluminum that you're dissolving out. The aluminum is an alloy. It usually has some silicon. What I'm not sure actually, but silicon alloys are very common. You could look up the formulation of 6061 aluminum. I'm pretty sure that's what this was, and know what is actually contained in the alloy. The good news is that whatever develops on the part while you're etching it, it rinses off, dissolves off very readily with nitric acid. Nitric acid is the standard approach for dealing with the smuts that most aluminums form when they're being etched. Even in the preparation for zincating aluminum, you will sometimes read about using nitric acid as a smut remover. So this part is actually looking surprisingly clean. You can see the gold color underneath there. A day or two ago, while we were still etching out a lot more aluminum, much more aggressively, there was no clue that this was actually a pretty gold-plated part when it started etching earlier in the week. So anyhow, my belief is, and we'll do a demo video on this, is that when we dip this into nitric acid, you're going to see the dirtiness of the piece just go away very quickly. It's Pan referred to it as almost magic when he saw this some years back. The nitric acid dip also has another purpose. If you go back to when we first made this component, electroformed this component, we started out by zincating the mandrel. We went from the zincate step to a thin layer of alkali copper, and then on top of that alkali copper we had gold, a heavy layer of gold. So as you're dissolving it out from the inside, the first thing you encounter is the aluminum, the mandrel. But then you bump into the layer of zincate, which is also dissolved away by the sodium hydroxide etchant. And then you bump into this layer of alkali copper, thin layer of alkali copper that's over the gold, and that is not touched by the sodium hydroxide. So after you've done the sodium hydroxide etch out of the mandrel and you look in, you're not going to see the gold inside there. You're going to see really an oxidized, corroded layer of copper, a very thin layer of copper, only a few microinches. So our final chemical step is to go into a nitric acid, rather strong, maybe a 20 or 30% solution of nitric acid. Sometimes maybe even warmed up a little bit above room temperature to make it more aggressive. But we use that nitric acid to dissolve out this residual bit of copper that's inside the part. And once that copper is gone, then you see the heavy gold plating layer that we put onto the mandrel weeks ago now. You know, we did this part, build up that gold layer, which becomes the interior finish. We went into the copper electroforming tank for about a week. It went to green bank for machining and soldering on of flanges. And then it came back to us for about a week of etching in this case to remove the mandrel. Now I say a week, it has taken a week, but that was a week of only etching it out during the daytime while we're attending the lab. If you were in a production mode, you would probably be set up to where you would etch 24 hours a day. So then instead of taking a full week to do the etching, you might be able to etch out a part in just a day or two. Especially if the machine shop has removed as much of the aluminum as possible, which wasn't the case here. They were pretty conservative about machining out the mandrel. I think they could have easily removed twice as much of aluminum without risking damaging the part, but not critiquing them for that. You know, we're not in a high volume production mode right now, and there always is a little bit of risk when you're drilling out the mandrel that you could damage the electroform and then you've ruined a part. So conservative is fine, but it just adds a little more time to the etching process. Anyhow, that's enough for now. We'll come back and shoot another video in a little bit and show the final acid rinse of this part.